about more examples in definite integral of how to deal with fractional algebraic fractions, especially when you involve quadratic as a denominator. Okay, so this question actually is very nice. First part, they already ask you to split 6x plus 16 into this form. Okay, so I'm going to just do this without using the first part, where I look at the question directly, okay, hence find the exact value of this. Okay, so all of you should be able to do the first part. Now in the second part, or rather, let's say the question did not give you the first part, what should be your thinking process? So if you look at this flowchart on the right, where I talk about integration by splitting the numerator, first, check you need to do long division. The power of the numerator is 1, the power of the denominator is 2, no need to do long division. 2, check if the denominator can factorize. So use your scientific calculator and go and press mode 522 or quadratic solver to see whether you can factorize nicely. And you realize that cannot factorize. Okay? So if you cannot factorize, we go to this step over here. Identify your fx and f prime x. Fx is the denominator. Fx is x squared plus 4x plus 13. So if I have f prime x, and all this can be part of your working, this is going to be 2x plus 4. Okay, but I have 6x plus 16, which means that my numerator, I have to split it into this form, 1, negative 2. Okay, 6x means I multiply by 3, there's a 3 of 2x plus 4 over here. X squared plus 4x plus 13. Dx. Okay, I split it to this part first. Now, are we equal? 2 times 3, 6. Okay, that's fine. 3 times 4, 12. But I have a 16 over here. In order to make everything equal, I compensate with another part, which is 4 over x squared plus 4x plus 13. Okay, basically whatever happens over here, this, and this, must give you equals to the numerator. If the first part, of course, is not given. Okay, so things like that, always think of f prime x over fx first. Then the second part, this is where I talk about this. Split it into f prime x over fx first, plus k over fx. So the first term over here, we can simply say that this is ln modulus x squared plus 4x plus 13. With my definite integrals, negative 2 and 1, okay, in the box. Okay, plus I put the 4 on the outside, the integrate negative 2 to 1, 1 over. I already know for a fact that my denominator cannot factorize. What is the next best thing I have to do? That would be complete the square. Okay, x squared plus 4x plus 2 squared minus 2 squared plus 13. Okay, at this point of time, your completing a square skills have to be there. Even when I do countless completing a square, I still go to the basic by writing these steps. Then I just put it in. Okay, so this will be ln modulus. If I put in the 1, 13, 17, 18 minus ln, if I put in the 2, okay, it's going to be 2 squared 4, 4 minus 8, 4 minus 8 plus 13, I'm going to get 9, okay, so ln modulus 9 plus 4. When I integrate this, I can't integrate yet, so I'm just going to write it in completed square form. This will be x plus 2 square. These three guys complete the square, yeah. Behind is plus 9, okay, dx. Oh, so when it comes to things like that, in ln form, we have ln minus ln. You have to apply your law of logarithm. That would be 18 over 9, ln u minus ln v. Plus, in this form, when it is x squared plus a squared, who is my x? This guy, x squared. Who is my a squared? So this is 3 squared. My a is 3. Then look at your formulas. Look at the formula sheet. If you don't have the formula sheet, then this is the part where I have written down for you in the given form. That would be sorry for the glitch. Okay, so the integral of 1 over x squared plus a squared form is this. Formulas are given to you. You have to know how to use it. So I'm just going to write. Okay, so when I integrate something that is in the form of 1 over x squared plus a squared, I'll just look at the formula over here, which is the one, this is the one that we are talking about. Okay, so now I'm just going to apply it in, okay, apply in inverse tangent, sorry, there's a 1 over a and my a is 3. 1 over 3 inverse tangent x plus 2 over 3 with my definite integrals negative 2, 1 over here. Okay, so now that we can put in the definite integrals for my tangent. This will become 3 ln 2 plus 4 over 3. Constant, we can always bring in outside. Tangent inverse, put in the 1, so that will be 3 over 3. 1 minus tangent inverse 0, and at this point of time you should know that tangent inverse 1 is pi over 4. If you don't know, please refer to the second video of this series. Okay, plus pi over 3. Okay, and this is how we do splitting, and when the denominator cannot be factorized, cannot be expressed into partial fraction form, then we complete the square and apply the formula, okay, to get our final answer.